All right, good morning, good afternoon. I don't really know wherever you're at. It's COVID time, so let's go ahead and get this started. So for our group project, we did a Pmod integration with our Cmod board from class, and this communicates via I2C. So over here on the right, you can see our Cmod A7 Arctics board, and right here you can see the Pmod Hygro that we're going to be using for this demo. Along with me today is Abed and William. And let's go ahead and get started. So for the following project, like I said, we use the Arctic 7 and the Hygro Pmod to transfer humidity readings via I2C, and we view these readings on the serial terminal of our board, which we connect to via the UART. So the Pmod kind of runs, well, it does run as a state machine, and it continuously executes through various states to update its values back to the master port. Behind all this is the Microprocessor, which is delegating all of the tasks for fast and efficient communication transfer via master and slave protocols. This is kind of another word for I2C. So I'm going to hand it over to William here to talk about the design steps for the project.
Hello, I'm William, and I'm going to go over the important steps that are needed to design this project. First of all, we want to be sure and use Vivado 2018 version. The newer versions have issues when trying to integrate these two boards. So we're going to gather the board files and the IP repository files for the Pmod. Then we'll start the block design in Vivado by adding the elements, the system clock, our two LEDs, the RGB push button, the Pmod, the reset, and the USB UART. So within the diagram editor, we'll add an extra IP, which will be our microprocessor. And with these components inserted, we're going to run the connection automation tool to route all of the wires of our design, and we'll use regenerate layout to organize the diagram so that it's looks nice. Then we'll validate the design and then wrap the design with an HDL wrapper within the source, and then we'll generate the bit stream for the design. With the bit stream exported, we'll launch the SDK tool. And from there, we'll, with our SDK launch, we'll create a new application project. We'll then copy in an example application to the source folder of the application, and we're going to edit the main.c file with our desired functionality. In our case, we're attempting to read temperature and humidity. So we're going to connect the Pmod to the Cmod board through the JA header ports and program the FPGA, and then we'll select Run Hardware as a system debugger and open the terminal to view the application running.
All right, so when we got our application running, we had a few problems. Not just running it with Vivado 2021, that led us into some huge issues, but when we got it running on 2018, the example program that we ran prints temperature and humidity continuously, and that happens via a while loop. And the reset push button would restart that code. So if you can see down here at the before picture, the temperature and humidity kind of just keep printing every second, and again, that's because of that while loop. Another issue we noticed was the humidity sensor was off by about 10% of an actual value, which we compared to a humidity sensor that Abed had. So the solution to these, we removed the while loop from the program, which allowed just the reset button to trigger one of these. And then we also added some customized terminology to the printf statement to to provide some instructions to the user of what to do to print the temperature. And as you can see in the after, we also added the course name, the professor's name, and our names here. So just comparing these before and after photos, you can see we had the while loop printing them continuously, and now we can press the reset push button, and that will print this out one at a time every time that we press it. So with that, if you have any questions or comments for us, you can email us anytime. But I'm going to go ahead and hand it over to Abed now, who is going to demo this project on the Vivado software. So Abed, go ahead and share your stuff, and thank you.
Thank you, Caeden. I'm going to go ahead and share my desktop over here so we can go ahead and show our Vivado. Pretty much setting up the Vivado project, we're going to open up and kind of go through the steps that we have learned in our class to open up a new project, except we're not going to add any sources or anything like that. It's going to be a completely empty project to begin with. But something different about this project, we're going to go ahead and use our create block design. That's going to allow us to bring in all these different blocks that you see over here to your right, and allow you to bring in the Pmod Hygro sensor, just like you can bring in any of the other Pmods that are available by Digilent's website. We're going to go to board. Under this tab right here is where you actually go ahead and add your system clock, your GPIOs, your LEDs, your push buttons, your Pmods, reset, which we're going to tie into one of the buttons, button 0. And then as well, our USB UART connection, which is going to let us communicate with the board through our computer, and let us print everything out through a terminal that we'll be showing here in a sec. So I'm going to try to expand this a little bit to see if you guys can see this a little bit better. And here's pretty much the whole entire assembly of these blocks that we create on here. You have a couple different things over here for you to utilize to be able to work on this project over here, and I'll go through some of those things that are needed here in a sec. But one of the important things about this is your timing and your reset. So here you have your reset block for your processor, and here's your clocking wizard. One important thing about the clock wizard is when you open it up, you go ahead and set out your outputs on your clocks. And this is where you can adjust your output frequency in megahertz. And for instance, in this case, we're going to set this one to 100 to work with our Pmod board. And being that we're using our Cmod board for this project, we're going to do our resets as an active high as shown on the Digilent website. Also, we can go ahead and look through these different modules. You can click on these modules, and you can, as you build them, there's more parameters of them. They're pretty self-explanatory, but as you can see, sometimes there's other modules that live within this. It's almost like when you're building your VHDL code and you have a top module, and then you have sub modules that live underneath that. That's the same thing that we're looking at over here. And this is all the RAM, how the RAM is composed right here, from local memory to BRAM to our block memory. So we'll go ahead and close this guy up. All of this connects back to our main piece right here, which is our processor. This is a Microblaze processor on the Digilent website, which if you look up any of your boards, it'll explain and let you know which type of processor you'll be able to use with your IP integration. In our case, the Cmod uses Microblaze as its processor. We tie in all of these devices right here, and through the connections of these GPIOs, our USB UART and RGB all communicate through our Microblaze processor through this AXI peripheral. This is also another communication that's being done within this program as well. But once this is all created, you're going to go ahead and hit over here, regenerate layout, which is just going to pretty much put all this back in order, because you'll probably see some of these devices kind of shifted around and stuff like that, maybe as that. So you can hit regenerate, and this will just organize the whole project for you. After you do that, you're going to validate the design, which is probably no different than doing a test bench. You're actually testing your design and you're validating to make sure that everything works properly. If it doesn't, you're going to receive messages on the bottom that'll tell you, hey, this is happening, which as William explained before, when we tried to use Vivado 2020.1, we had nothing but problems. We could not get it to work with that design, But once we went to the 2018 version and went with the old SDK, which was used in 2018, everything seemed to work properly as it was supposed to. The new 2020 version uses a new SDK, which is called Vitis or VTs. So once we go ahead and validate design, we're going to come over here and we're going to go back to our block design that was created, and everything kind of lives underneath this. But the important part is that you actually wrap this guy, because this is going to need to be done to allow this guy to be able to generate bitstream and to be able to export it to the SDK. So we'll go ahead and create the HDL wrapper. At this moment, it already has been wrapped. And then we can go ahead and go to the bottom and generate bitstream. Once this process is done, and everything appears and works as it should, and then the bitstream was successful, you're going to go ahead and go to File, and you're going to export this hardware and export it with the bitstream, so that way it can be used for your project in the SDK. Then after that, we're going to go ahead and launch the SDK, which is also under here, Launch SDK. And when you do this, it lets you set up the SDK folder to your local project that you're creating. I already have it open at the moment, so we're going to go ahead and go to the SDK. And the SDK is where you'll see the platform that was created when you exported that. And we're going to also have to create an application, your software for this actual device. So that way, once you program this device, you can run your software, which is going to tell it to do what we want it to do pretty much. So we go to File, we go to New, and then we could go ahead to Create Application, which is to the right on the very top where it says Application Project. So you create that application project, and then underneath your source folder, you're going to go ahead and take from the VHDL wrapper project that you had. You're going to open up your Pmod, which is also in the drivers folder of this wrapper. And you're going to take the example project that's in there, and you're going to go ahead and either copy and paste it over here, or you can make a file over here called main.c and paste the information in there. So once you do that, you're going to open up your software, and then you can go ahead and edit here in C and edit everything to make it kind of different. So in this case, like Caeden explained, we had some difficulties with our sensor being off calibration. So we went ahead and added to the software an offset so we can go ahead and calibrate that guy and get it to read properly in reference to another temperature sensor that I had available over here. So let's go ahead, and I'm going to go ahead and just run this program. What you do is you hit this program button over here. Make sure this guy is selected over here, Hygro application, and then we're going to go ahead and run that software. So when we run this software, we go to Launch on Hardware, System Debugger. I have it launched already, but I'm going to go ahead and hit OK. Once that happens, in your SDK terminal, which is already up, you're going to see what just printed out. Every time I hit reset, which is button 0, if you recall, you're going to go ahead and see that it gets printed all over again. And look at the temperature. Right now we're at 71.83 with a 51% relative humidity. Print again, 71.84. Print again, 71.83. So you can see that the numbers are actually changing. Things are working over here with our guy. And this is the temperature that is being read right now in this room, which in the next video will show, next portion of the video will show like a live demonstration of the Pmod board and also the temperature sensor next to it, which we use to calibrate this guy. I'm going to go ahead and show a demonstration also of the original software that was written for this guy. I'm going to go ahead to the program that I use called Sublime just to copy that information. I already have it highlighted here. I'm going to copy it. I'm going to go back to my SDK. I'm going to go to the main C file that I have open and just paste it in there. Once I paste this guy, all I have to do is hit Control S, save it, and then I'm going to go ahead and run as, and we're going to go ahead and run and launch on hardware again. Once I do that, you're going to see that this guy starts scrolling. This is what the original application did. Before, our humidity was showing at 50%, which is pretty accurate. Now it's showing 61, so the original program was a little bit buggy. And as you saw, we added our own text with our class information, our project information, and as well as how what you need to do to actually get new temperatures. But this will run on forever and display and actually reset every second and kind of update itself over here, as you see, with the temperature and humidity. So I'm going to go ahead and shut this guy down right now, and then we'll go ahead and go to the video of the live Pmod actually working at this moment. And I don't know. All right, so this is the live demonstration of the board and what we have going on right now. As you can see, this guy from the last program that we saw where it actually constantly resets and updates the program, you can see this guy constantly going, and this goes along with what's being printed out on the screen. We also found out that if we actually plug in, because you can plug in these Pmod headers or these Pmod sensors directly to your JA header, and it will work no problem. But we did notice that while it was connected, it actually, the warmth or the temperature of the board is actually affecting the temperatures of the room. So we went ahead and removed it and connected it separate, so that way the temperature that's being displayed shows properly as well. So here's a little sensor that I used, and this little guy right here is actually pretty accurate. I tested it against another a Fluke sensor, a more expensive sensor recently, probably like a couple weeks ago, because I wanted to know what the humidity and temperature was in this actual room where I'm at right now. And this guy was spot on. So I think overall, this kind of shows what are the capabilities of Vivado, what you can do with Pmod sensors, and how you can make this all work by using or implementing IP block designs. So here's the software, and here's a screen showing. So as you saw that little light that was constantly updating, this is what happens. Every time that little light goes off, that's what's being printed right there. And thank you for watching our demonstration and our project. Thank you.